Hello, welcome to Venn diagrams, questions 4. In this question, we're given the probability of events A and B, but we're also told that they are independent events. Now, to answer this question, we're going to have to use the multiplication rule of probability, which is this. And for independent events, we get the probability of A intersect B is equal to the probability of A times by the probability of B. I'll probably end up doing another video just on the multiplication rule of probability, and when I've done it, I'll link it down below. But for now, we'll just use the rules. So for part A, we have to find the probability of A union B, which, as we know, is the probability of A plus the probability of B minus the probability of A intersect B, so we only end up with one of those sections instead of two. But as we know that the probability of A intersect B for independent events is the probability of A times the probability of B, we get this. And as we have all of these values, we can work it out by adding 0.3 plus 0.5 and subtracting 0.3 times by 0.5, and that gives us 0.65. Alternatively, we could multiply the probability of A by the probability of B to get the probability of A intersect B, and then write this value on the Venn diagram. And this works out at 0.15, so if we write that in here, and then we can fill out the rest of the Venn diagram because we know the probability of A is 0.3, therefore this section must be 0.15, and we know the probability of B is 0.5, so this section must be 0.35, and outside the circle must also be 0.35 so that all those values add up to 1. And then you'd be able to work out the probability of A union B by adding up all the values within this area, and it also gives you 0.65. Next, we want to find out the probability of A complement intersect B. Well, for independent events, that's equal to the probability of A complement times by the probability of B. Now we know the probability of A complement is 0.7, and we can get that value in two ways. We can either add up all the values outside of circle A in the Venn diagram, or we can subtract 0.3 from 1, as we know that the probability of A plus the probability of A complement must equal 1. So we have all of the values to work out the probability of A complement intersect B, which is 0.7 times 0.5, which gives us 0.35. Of course, if you had completed a Venn diagram, you could read that value straight from the Venn diagram, as it's this area here, as it's everything outside of A that is also inside of B. Next, we want to work out some conditional probability, the probability that B occurs if A complement has happened. Well, if A complement, this area, has already occurred, the only way B can occur is within this area here. So we could work this out as previously, putting the probability of A complement intersect B over the probability of A complement, which gives us 0.35 over 0.7, which is 0.5. However, for independent events, the probability of B on condition of A complement is the same as the probability of B, which is 0.5. In this question, we're given the probability of A, B, and A union B, and we're asked to determine if the events are independent. Well, we know that the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersect B. Now, we've said that so many times, you probably know that off by heart by now. So we can rearrange this and work out the probability of A intersect B, which is equal to 0.2 plus 0.5 minus 0.6, so that's equal to 0.1. Now, if the events are independent, the probability of A intersect B would be equal to the probability of A times by the probability of B. So let's work that out. The probability of A times the probability of B here is 0.2 times 0.5. That equals 0.1. So therefore, we know these events are independent. So that's it for now. I hope to see you on the next one. Meanwhile, if you are finding the videos helpful, then please press like and subscribe. That'll be brilliant. If you've done it already, I really appreciate it. Thank you. See you soon.